Sixth grade lesson 11.1 is three-dimensional figures and nets. They start by telling us about a solid figure. A solid figure is a three-dimensional 3D figure because it has three dimensions. It has a length, it has a width, and it has a height. So solid figures can be identified by the shape of their base. If their base is rectangular, we might call it a rectangular prism. Or if their base is triangular, we would call it a triangular prism or something to that effect. They are identified by the number of bases they have. If they have two bases, they're a prism. If they only have one base and then the other sides, the lateral sides meet up at the middle, then it's a pyramid. And then they're identified by the shapes of their lateral faces as well. So let's kind of look at a three-dimensional shape and identify the vocabulary that goes along with it. Some will be review and some of the vocabulary will be new to you. Okay, here's some vocabulary words for this triangular prism. Its base is a triangle, so we're calling it a triangular prism. It has two bases. It has this triangle here and then the underneath triangle at the bottom. That is its match. Okay, so that's the base. The lateral face. These sides are lateral face. So this side is a lateral face. So is this side. It's the faces that connect the bases to one another are called the lateral faces. That's probably a new word for you, I think. Something that's probably not a new word is a vertex. Maybe you've forgotten, though. It's the little corners. Vertex. Plural is vertices. These are all the vertices, all the points, the corners that will hurt if you poke it. And then another word that's probably not new to you is the edge. Edges are where that kind of straight line is formed from vertices, between the vertices. So there's the edge. That's an edge, that's an edge, that's an edge, that's an edge, that's an edge. There's all kinds of edges on a three-dimensional figure. The next vocabulary word I want to introduce you to, I think this is an introduction to a new vocabulary word in terms of geometry, and it is nets. I will admit to you, I'm really not great with nets, just because my brain doesn't work in a very spatial way. Some of you are going to be like, oh, this totally is easy. Ms. Sanchez, I don't know why your brain isn't making sense of it. It just takes a little more for my brain to take the time to visualize what's happening. I can do it. I'm just not great at seeing it right away. So a net, what you really want to do is kind of let's imagine that this rectangular prism is a cardboard box. And let's say I want to cut and lay out that three-dimensional cardboard box into something flat so I can see all the shapes that build that cardboard box. So that would be called the net, the flattened version of this cardboard box. Okay, just be thankful for the pause button. That took me an unreasonably long amount of time to get my brain to filter that through. This is the base. This is the base on the back. And then this is the unfolded versions of these four lateral sides. So this whole thing is the net of this shape. So it's just the cardboard box flattened version of this. It's useful because when I have to find the surface area of the box, surface area would be, for example, if I had this block and I wanted to paint it, all of the outside of it, I would need to know how much paint I would need. So I would need to find the area of every part of the outside. So I need to find the area of this, area of this, area of this. And if I only see three sides, I have to really try to work to imagine those other three sides, though they should be matches. Having it visualized as a net can be helpful when you have all the dimensions laid out. So, and that's where we're going, is into surface area, just a heads up. So this lesson will allow us to practice the skill of recognizing the nets, the flattened version of these three-dimensional shapes. Some of you are going to rock this and be really good at it and wonder why Mrs. Sanchez struggles with it. And some of you are going to be like me and be like, oh, it takes me so long to kind of picture and figure out and draw it. But don't worry, you still can do it. It will just take, if you're like me, it will just take your brain a little bit more energy and a little bit more time to get it viewed that way. So let's look at this unlock the problem example. A designer is working on the layout for a cereal box that's shown corn twisties. Identify the solid figure and draw a net that the designer can use to show the placement of information and artwork on the box. So how many bases are there? Well, if I'm calling this my base, there's this base and the bottom, which would be congruent to it or identical to it. So there are 2 bases. Are the bases congruent? Yes, they're going to be the same value, same dimension, same length, and same width, right? And what shape are the bases? That's a rectangle, so the base at the bottom is also a rectangle. Let's identify the solid figure. Remember that a prism is a solid figure with 2 congruent parallel bases, which we just talked about, the bases. Its lateral faces are rectangles. It will be rectangle, 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 rectangle. And it is named for the shape of its bases. So is the cereal box a prism? Yes, it has rectangular lateral sides. Its bases are rectangular. So yes, it is a prism. If the bases were a different shape, it still could be a prism. If the lateral sides are rectangular, then you're good. Okay. What is the shape of the bases? They are rectangles. So the box is a rectangular prism. Now they say draw a net for the figure. Again, this is my brain taxing sort of thing. A net is a 2-dimensional figure that can be folded back into that solid figure. So it's the unfolded version. So we would make a list of the shapes we will use. Well, we used our bases, this part as our bases. So they're going to be laying on that outer part. So if you can imagine this being cut here, here, and here, and then laid flat, peeled flat, and then this over here does the same. Then we cut along here and unfold it all across here. This is what they've done here. They've got the 2 bases, top and bottom. They cut along there, and then they unfolded the whole thing and laid it flat. So you have the front, the back there, this side here, and that side there. So we have the top and bottom bases that are rectangles, the left and right faces, which are rectangles, and the front and back. Well, I guess this is front and back, and this is the left and right faces, which is also rectangular. All of them rectangles. And so just remember that prisms have rectangular lateral sides. The base might be a different shape, triangle, but you'd have a top triangle, bottom triangle. And so when you unfolded everything, you'd have the 2 triangles on the sides and then a bunch of rectangles, because a prism unfolds with lateral sides becoming rectangles. A pyramid is a solid figure with a polygon-shaped base. It could be any shape. It could be triangle. It could be rectangle. And it will have triangles. A pyramid will have triangles for its lateral faces. Prisms had rectangles for its lateral or side faces. Pyramids are going to have triangles for its lateral faces. So like prisms, pyramids are named by the shape of their base. A pyramid with a rectangular base will be called a rectangular pyramid. If it has a triangular base, it will be a triangular pyramid. So let's take a look at a pyramid. Okay, so here I have a pyramid, and they want me to describe the base of the figure. I think of the base of the pyramid as the butt of it, the part that it's sitting on, and that's a triangle shape. So the base of the figure is triangular. Notice there's only one of those on a pyramid. Rectangular prisms had a base and the matching on the top, so the bottom and the top were matching. But on a triangular or on a pyramid, there's only one base. Describe the lateral faces. These lateral faces are all triangular. So this figure is a triangular pyramid. If the base had been a square, I would have called it a square pyramid. If it had been a rectangle, I would have called it a rectangular pyramid. Let me show you what that looks like. So there would be a rectangular or maybe a square. I don't know. I don't know the measures of that, but the base is either rectangular or square. And then the lateral sides that build up to that little top peak, those are triangular. So if those lateral sides are triangular, you have a pyramid. All right, here's the tough part for me. They want us to use shapes to use in the net. They want us to make a net of that. For some of you, like I said, your brains are like, oh, I see it already in my head. The base is a triangle. So I'm just going to, oops, let me put better color. Triangle. And the lateral faces, there's 3 of them. There's only one base. And then there's 3 of the lateral faces, which are also triangles. So I need to figure out, if I cut one side, how that's going to look as I lay it out. Give me a moment. I'm going to pause this and draw it. Okay, there it is. There it is. So if this was my base, I cut, folded it down, and then this would, if I were to fold this back up, this part would be this wall back here, and then these would wrap around this one and this one. They wrap around, and so I have a triangular pyramid. That's the net for my triangular pyramid. All right, and so equally difficult for me is moving from a net back into a 3-dimensional figure, and that's what example 2 shows us how to do. What I do notice is that I've got these 2 triangles here, and then I've got rectangles. These lateral sides are going to be my rectangles, and I know that pyramids have lateral sides that are triangular. Prisms have rectangular lateral sides. So I know I have some sort of or I have some sort of prism, I should say. So the net has only 2 triangles, so it cannot be a pyramid. And since it's not a pyramid, and these are my lateral sides, then what's left is my little triangles, and those must be my bases. So the triangles must be the bases for a prism. So I am going to draw a prism that has the triangle as its bases, both bases. So it will go like this. Oh, a different color. This. And then back here, well, I'll just go ahead and draw that out. And then you will have that there like a tent. I have my triangle front, my triangle in the back that you really can't see, which represents this guy, and then my 3 rectangular pieces. Rectangle, rectangle, rectangle underneath. So a little easier for me to do from net to prism, especially since I knew what I should be seeing because they walked me through it. But sometimes it's more complex than others. I'm not very visual. Some of you will run into that too. Others, you guys are just going to be like, oh, I could totally do this. So anyways, the whole lesson gives you some practice at it, and that's all you're doing with this is turning 3-dimensional figures into a net, or looking at a net and trying to figure out how would that fold back up into a 3-dimensional figure. So think of it like a game, think of it like a puzzle. You've got this.